This is checkpoint 2.49. They want us to find the equation of the line formed by the intersection of two planes. And let's just say, this is one of the planes, and let's say this is another plane. Let's say it kind of looks like this. And let's see if we can draw the illusion of the intersection. Between these two planes, and they would intersect on this line. Guess I kind of drew this this plane a little too far. All right. Well, in any case, we need an equation of that line. To find an equation of the line, we need a point and a direction. Let's focus on the direction first. In order to get the direction, what we're going to do is we're going to take advantage of the normals to the first two planes. So this plane has a normal vector, and the other plane also has a normal vector. And those two normal vectors, when we take a look at them, when we cross those two normal vectors, we're actually going to get the direction that we're looking for, the d vector. Okay, so let's try to get the normal vectors for the first plane. So let's call the first normal vector n1, and that will be 1, 1, the coefficients 1, 1, negative 1. And let's find the normal vector for the second plane. Let's call that n2, and the coefficients are 3, negative 1, 3. Okay, and we take the cross product, we're going to get the direction that we want. So D will equal to the cross product of n1 and n2, which is going to be set up as a determinant of a matrix 1, 1, negative 1, 3, negative 1, positive 3, and in the I direction we're going to get 3 minus positive 1, so 3 minus 1, and in the J direction we're going to get a negative 3 minus negative 3, so that would be 3 plus 3, which is 6. And then in the K direction we're going to get negative 1 minus 3, so that's negative 4. Okay. All right, now that we have the direction, we need a point. And the way we're going to find the point is, let's make a note here. To find the point, what we want to do is we want to basically set two of the variables, or set one of the variable equal to a constant, and then see how it's going to satisfy the two equations. I'm going to set z is equal to 0, and I just randomly chose z, but you could have let other variables equal to whatever you want, and then you're going to plug it into the equations. So the first equation that we have for the first plane is x plus y minus z, which is going to be set equal to 0. Is going to set up an equation. I mean, we really don't need that symbol anyways because it's going to be 0. And then the other equation of the plane is 3x minus y plus 3z is equal to 5. Okay, so this is set equal to 0. These two things are set equal to 0, so they'll disappear. Okay, now we're going to solve for this. We have two equations, two unknowns. Looks like we can just add them. We're going to get 4x is equal to, and here we have 3 plus 5 is 8. So x is equal to 2. And then we put one of them into one of the variables. And then we're going to get 2 plus y is equal to 3. So y is equal to 1. So we have the point 2, 1, 0. 2, 1, 0. Now that we have a point and a direction, we can write the equation of the plane. The point is 2, 1, 0 plus t times the direction 2, -6, -4, and then we put them together and we get the x variable equal to 2 plus 2t, the y variable equal to 1 minus 6t, and then the z variable equal to 0 minus 4t. So different equations could arise here, and they're not all going to be the same depending on what point you chose or how you crossed the two vectors. If we crossed them a different way, then it'd be the opposite. You can also factor a 2 out, so that's going to give yet a different set of vectors. So there's many answers to this, but this answer should work. Okay, I hope that helps.